Okay, let's start. So last day we discussed up to these management activities and also about the operating systems that are in, and today we have to start about these management events. So we have different kind of, so the operating system is a resource manager. So why we need manager? So for let's think about any kind of organization, institution, or some company. So why there is a requirement for manager? Because there are resources, multiple resources, and there are multiple parties accessing those resources, right? So then this is very simple explanation. So let's say there are some resources, and this side I can draw. So these are some resources. These resources are accessed by different people or different services or different other entities. So these are the entities accessing these resources. And why you need management? So you need management because, so if there is only one entity accessing these resources, no need to use the management. If there's only one, so no need to use the management. Then this one resource, then it can access this one, no, this one, and one resource, one person. Then the person can decide whether when to access, how to access, all these things this person can decide if there is only one entity accessing one resource. But even one entity accessing many resources, and not just that, you can see many entities accessing many resources. So that can cause some troubles, or you need something in the middle to facilitate these multiple access. So there are resources, and the other side you have consumers. So different consumers consuming different resources. So since it is a limited, right, you need something called management to access these resources. That is why you need the management. Manager or management is there in the middle. Why there is a management or manager in the middle? Because the manager or management can access the resource, can facilitate how to access these resources and how to consume these resources. So that is why there's a management, right? One resource that we are going to learn today is file types. One resource that we are going to learn today is file types. A file has a file name and extension, so that we already know. A file has a file name and also a type of file, which means file extension. And so just an example, you can say the file is ABC and docx. So here ABC is the file name, docx indicate the file type. So docx tells that it is a Word document. So likewise, different kind of files, different type of files are having different file types. So then CDF dot let's say PPT is a PowerPoint file. So file types and file type is decided basically using this extension, and extension will help, right? Extension will help us identifying the file type, the default program to open that. Extension will help us identifying the file type, the default program to open that file, and also how to open that file and what is the icon and other properties. So everything will be decided by this file extension, right? And so in addition to that, the file has some properties. These properties are related to security, date access, date modified, date created, or the file is whether the file is read-only, hidden, or system. So those are some other status of the file, right? Files basically are managed. The basic unit which store file is called a disk or a drive, basically a disk. So here, let's say this is hard disk, and this hard disk okay, sorry. So then, so this is, let's say this is the disk. The disk is allocated to these files. So, but the disk has some proportion allocated for the file organizing, which is called the file format. So when you format the disk, it will create a file system. Let's say one portion of the disk is allocated for the file system. This is that portion. So this is allocated to file system. File system can be this NTFS, CDFS, FAT, FAT32. Sampurna disk ekama denne naha apita. Entire disk is not allocated to the files. So one portion of this disk is representing the file system. So it needs some space. Like the file system decide how to store the files. File system decide how to store the files, whether to so it will, so file disk is basically divided into clusters, sectors. So I'll show you an image. So this is hard disk. You need to know about the clusters, sectors, and tracks. So logically, hard disk is divided into, here you can see this image. So logically, hard disk is divided into, so this in a round also you have this is a platter. This is the hard disk platter, and it is divided into tracks. So you can see that is in the red color, or this light red color, there is a track. And there are a number of tracks in this hard disk platter. So track is then divided to a sector. You can see the sector, right? Then it's divided. So this vertical slices or sectors, and sector and track, intersection of the sector and class, sector and track is called a track sector. This is track sector. And that is the smallest unit that you can see. This is done by the file system. File system එක තමයි මේ විදිහට මේක decide කරන්නේ. File system divide hard disk into the, so no physical borders, right? No physical borders, but it divide into sectors and clusters, and then sectors, sorry, it will divide into tracks and sectors, and these sectors, multiple sectors together forms a cluster. Cluster is the minimum storage unit. So you need to know about this tracks, sectors, clusters, and all. Okay, here you can see the green color one, it's a track. Track sector is blue color, and cluster is multiple sectors. Multiple sectors together you can call a cluster, right? Okay, so this is how the storage is created in related to, this is not going to come in the operating system part, but it is available in so it's available in the hard disk or the file structure, right? If you want to see the structure, I invite you to visit this link. How hard disk works. There is animation, nice animation in this website, Anima Drafts. I'm not going to load it now. I'll send it as a chat link. You can just visit and see. So it shows how the hard disk is there, right? You need to know about that in order to know these file systems. Otherwise, you won't understand what these file systems are, right? So that is the hardware structure, right? Animation එකේ තියෙන hardware structure. When you see this, let's load it. Okay, but then now you can see the clear image of this, and you can see these are the platters. Platters are rotating, like because the spindle is connected to a motor. It's rotating a constant speed. So then what will happen? The actuator is moving its arm. This actuator arm has the read-write head in the corner. It's moving back and forth. Then by it can read the entire disk. This is similar to the gramophone, right? I think you have seen at least in a cartoon like Phil Stone cartoon, you have seen this gramophone style. I'll show you that image if you can remember that. And then, so this is what happening when reading and writing. Actually, since these heads are accessing all the surfaces, surface means the top surface and bottom surface. So how many surfaces in total in this? So there are 4 platters. 1, 2, 3, 4 platters means 8 surfaces, right? So because the top surface, bottom surface, top and bottom, top and bottom, top and bottom, there are 4. 4 into 2 is 8 surfaces. In all the surfaces, as I saw that in the image, it's divided to the clusters and sectors. So here actuator is right into the entire cylinder. What is cylinder? Cylinder is this intersection of these sectors, or sorry, tracks we can call a cylinder, right? So if you have like doubt, so when you have this, you can see 8 heads, 4 platters, 8 heads. So you have surfaces. So what is a cylinder? Here, track cylinder. Cylinder is here to here. You can see here in this image, here to here, the consequence like here to here, consecutive tracks. Consecutive tracks forms a cylinder, right? So here sector and cluster. I'll show the relationship between sector and cluster practically. Now you know what is cylinder, right? So you can see here, it's a cylinder, right? Cylinder is, you can see the cylinder is consecutive tracks. It's going from top to bottom or bottom to top. So it writes the entire cylinder. How the writing happens is explained here in this animation. When the read-write head moves, it magnifies the surface. It magnifies the surface because magnet has north side and right side. A magnet has north and right. So it magnifies the surface. So by that magnification will result this 1 and 0 in this. Okay, I think it's clear now. You know how the process is happening. Yeah, other parts are not really related to this. Okay. Then data written into these sectors like 1010, that format, data written into these heads. There is general awareness about this hard disk and its file system, right? Now let's move to the, okay. So this file system will store, there are different file systems. Different file systems are deciding how to store the files. Right? Basically, one thing is this hard disk. Sometimes you need to partition this. Partition means divide this hard disk into manageable. So you know the partitions or rooms in a house. Why there are rooms in a house? What's the reason? Yes. Why there are rooms in the house? Why can't be a single building? Yes.
To separate.
Why there's a kitchen? Why there's a bathroom? Why there living room?
For different tasks.
Yeah, for different tasks. So what happen if can't we put all these things in a single building? Still can, right? Still can, but the thing is then it's mismanaged, highly mismanaged. Everything is in the same thing means it's like mismanaged, because when you cook something in the kitchen, the smell come out and spread everywhere. And okay, when you are in the bathroom, again, if proper sanitization process is not there, right? Because you know the bathroom need to be cleaned rapidly, and it's wet most of the time, so it need to be cleaned, and proper ventilation should be provided. So that is a separate thing. So do the kitchens. Kitchen also need separate ventilation. Right? Kitchen also needs separate ventilation. So that is, then the living room or maybe the dining, living, there are different places. The reason is you need to manage it. That's why for manage, it's easy to manage when there are different partitions, different rooms. Because in the hard disk also the same operating system, you can put it to one disk. The operating system, you can put it to one drive. And then your entertainment files, another one. Your software into another one, maybe your backups and other things that you want to access, you don't want to access rapidly, you can keep it in some other drive. The advantage is, let's say the operating system is damaged. You don't want to worry about other files because your entertainment files are secure, your regression files are secure, software are secure. Only your operating system got damaged. So you can replace or you can reinstall it. That's the nature, right? So that is why you need different partition. Partition means the physical disk you divide into logical sections. So that is called partition. Right, then in this partition, so then the file system comes inside this partition. Different partitions can be formatted with different file systems. Let's see it now. So I really prefer if you can share the screen, then I can show you these things practically. Wait, I'll give the permission. So, okay, it's given. Now you can. Okay, let's go to this PC first. This PC, and right click and go to manage. Right click on this PC and go to manage. This PC, okay, right click and manage select. This right click on this PC, which is in the so you can right click in the right side. Sorry, left side. Left side, you can see the tree. Yeah, here. You can just right click on this PC. Then manage it. Managing is administrative activity. Sometimes it asks you permission from the administrator. If not, it will display this management console. It's a very important component there. So go to the disk management and you can see how your hard disk is managed by the computer. You can just see by using the disk management. Okay, Senali, in this case, you have two disks. So one disk is your hard drive. It is only 120 GB. I hope it is SSD, right? Is it? It seems it is SSD drive, right? Solid state drive, because it's a 120 GB means very small. And there's another one. I think this is a pen drive, right? Is it? E is a pen.
Yes.
E is a pen drive. The other one is hard. So I asked last day to bring empty pen drive, right?
Yes, sir.
Yeah, okay. Is this empty?
Yes.
Right. Okay. Then we can do some experiments with that. Right. Then here you have your hard disk, and you can't further divide it to partitions as you have already filled the partitions. How many partitions are there? You can see in your disk. There are 1, 2, 3, 4 partitions. And from those 4 partitions, system allocated space is there. So that has no drive letter. And this is a recovery partition that has a drive letter allocated for recovery purpose. And this is for your operating system and other files. So unfortunately, you have one partition for all these things, but still it's okay because this is small. You cannot allocate much. So my hard is also similar size because I am using Mac. And this is your other recovery healthy partition. You can see that, right? Okay, then you can see the file systems, different file systems in different partitions. Operating system NTFS, recovery NTFS, system NTFS, but Senali E is FAT32. Right, it is FAT32. That is different. Okay, can you right click here? And Yeah, you can do small tasks like change in drive letter, format, those things are available. Okay, let's move to format. I hope this disk is empty, right? Okay, format. For the moment, just yeah, you can check yes. Then it will ask, don't click OK. It will ask the file system. This is very important. Let's put NTFS. Then ask in the allocation unit size. This is actually the cluster size. Let's put large clusters, right? Okay, 64K clusters. Click OK. Just remember the figures. NTFS 64K. Okay. Yes. Formatting can be done in other ways also. Can you close this? No need to go to the management console. You can format by just right clicking on the drive here, right? Then also you can select format. Okay. Now don't format it because we have already formatted. So what we are going to do is, can you go to desktop? Okay, select some file. I prefer, create a new text file. Create a new text file. Right click, new text file. And open that text file and type 1000 characters. 1000 characters. No. So this will not give the 1000. It's difficult, right? So I think the easiest way is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Type 0, 1, 2, 3, 4. It's O, it's not 0. Okay. Now you have 10 characters. Copy that. Select, copy, Control C, Control V, Control V. Again V, 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 and V. Okay, now don't do that. So do it manageable way, right? Undo again. Control Z to undo. Control Z to undo. Okay, paste it only 10 times. Don't paste more than 10 times. 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 9, 10, enough. Copy it again. Now you have 100. Copy it again. Now paste 10 times. Control C and paste it 10 times. 6, 7, 8, 9, 10. And you can see here, only 10. You have pasted 11 times, but it's okay. It's okay. Otherwise, you are going to erase that. So you can see here, it's showing the number of pasting. Now you have 1090 characters anyway. No, just remember the figure 1090 characters. Well, in 1091 wala. So you are in 1091 means you have 1090 characters, right? You don't think much about that. Now save it. Save it. Save. Close it. Okay, now go right click and go to the properties. Right click and go to the properties. Right click and move to the properties now. Properties. Yeah, click on the properties. Yeah. Now you can see you have 1090 bytes. 1090 characters. That will give you 1090 bytes. Here. 1090 bytes. It has taken 4 KB. 1090 bytes. It has taken from your disk. It has taken 4 KB. This indicates one thing, Pute. The smallest unit in your hard disk is 4 KB. The smallest unit in your hard disk is 4 KB. It's the main indication. Let's copy and paste this file to your pen drive now. Let's copy and paste this file to your pen drive. Okay. Now see the properties by accessing the pen drive. Now go and see the properties. Okay, now go and see the properties. Now you can see same 1090, but it has taken 64 KB. What's the reason? What is the reason? Yes? What do you think? What is the reason?
Because we have taken big clusters.
Yes, we have decided to format this with 64 KB clusters. Can you understand what cluster is? Cluster is an integer. So cluster is basically one or more sectors. If you merge, let's say you have merged a lot of sectors. Now your cluster has more sectors. Lot of sectors together, your cluster is bigger. So what is the advantage of having bigger clusters? Bigger clusters, what is the advantage?
Easy to manage.
Yeah, easy to manage, and also the transactions will be faster. Copy and pasting things will be faster, right? එක හරියට ලොකු බැරල් එකක වතුර අයින් කරන්න ලොකු බාල්දියක් දෙනවා වගේ. If you have a big bucket to move water in a big barrel, so you can move it quickly, right? Because these clusters are bigger. You can create files, you can create large files and all, you can create easily because clusters are bigger. But this is not good for small files. If you are putting small files, it's not good. Or text file logge දානවනම් මේක හරියන්නේ නැහැ. But if you put image files, if this is a digital camera, maybe digital camera image will be like 6 megabyte. So large images. Then large clusters will definitely help. If you have large images, then large clusters will definitely help and it will make this faster. 6 MB එකක් ගන්න අර පොඩි බීකර් එකකින් වතුර ගෙනාවා කියලා හිතන්න. 6 MB කියන්නේ ලගන් ලොකු එකක්. අපි හිතමු ලීටර් 6ක්. ලීටර් 6ක් පුරවන්න මිලිලීටර් 100 බීකර් එකකින් වතුර ගේනවා. It's very slow. So if you want to fill 6 liters, and if you 6 liters, sorry, this is the using liters, 6 liters, and you have 100 milliliter beaker will be slow. But if you need to fill 6 liter, if you have 1 liter bottle, then that will be faster. So larger clusters will make the device faster, but it will definitely waste the storage. Why? So let's say you have small files like this 1 KB files. Even for 1 KB, it needs 64 KB, which is a waste, right? You have to decide based on the type of file. Your operating system, don't format that with larger clusters because it will definitely waste your storage. Operating system files are, most of the files are smaller. But if it is for keeping images, movies, better to have large clusters. You decide what to do. So now I think you have idea about these clusters, right? And one more thing, Pute. So can you create a folder there? No need to create. Can you see the, okay, go to the properties again. Go to the properties again, right click and properties. So not these tabs, you have general, security, details, right? Go to security. You can see different users can be given different permissions in the security. That is a feature of NTFS. Everyone is given permission to full control, modify, read, write. You can decide this. You can edit this. Edit. Edit. And you can add, let's say, add a user. So let's say, let's put some name, maybe admin AD, and search, check names. When you check names, you'll get some. Okay, no such thing. Cancel it. Go to advanced. Advanced. Yes, there you can find the users. Find now. There are some users. You can decide which users are given which permissions. Let's say administrators. Select that. Okay. Double click and click OK. Okay, now click OK. Right. Cancel it. You don't need this ADI. Is it cancel karena? Here also, can you cancel this AD? Can you erase this AD? You don't need that. Okay, click OK. Okay. Now you can see administrator. Administrator can be given all the permissions. Allow all. Allow all. Okay. Then everyone, go to everyone. Everyone means others. You can like deny some permission. Everyone, you can just deny some permission. Let's say write permission, you can deny. Yeah. Read and execute, write some permission. You can apply that. Likewise, different users can be given different permission levels to access these files and folders. Click apply and OK. Yes. Okay. Okay. Right. That is it. These are called NTFS permissions. Can you create a folder? Right click, new folder there. And go to the properties of that. Let's go to properties of the folder. Okay. So now you can see this security property. They are also a security case. Right. Okay. Now we are going to format this again. Let's right click on the pen drive. Format. This time you have to format this with FAT32. Yeah, that should be FAT32. And allocation unit, you can decide what to do. Maybe anything that you like. Okay, format with. Then quick format again. Format again. Now after doing that, please copy and paste the same files. Copy and paste the same file. Okay. Now see the properties. you can witness that the security is missing now. You don't have any security permissions there. It is missing now, right? Instead of that, general and details are there. Okay, that's what I need to show you. So NTFS has something called security here. NTFS has security, but FAT is simple. It uses less space. It doesn't have something. It doesn't have something called security. So that is the thing. Shall we write down this quickly about the file types and also about these file type behaviors and file systems? No need to write down this Sinhala one. No need to write down this Sinhala one. I'll just mark it in red color. No need to write down that, except that the other part you can write down. Just quickly write down that. We need to know about one more thing other than this clusters and sectors. So you know that the minimum allocation unit, we have formatted and identified that the minimum allocation unit is the cluster. Cluster is one or more sectors. Cluster is basically one or more sectors. And you know the sector and you know the tracks. So files, when you put the files, you can allocate these files in some of the ways. So one way is you can allocate that as a fragmented allocation. Fragmented allocation means you divide file into different fragments and store in adjacent, like store in clusters. So, but not in the adjacent clusters. You put it here and there. Maybe depends on the space. Let's say you are you and your friends going from one city to another city using bus, and you want to like sit together, but when you are there, you can see, you can witness some seats are filled. Some seats are filled, so you can, but still you want to sit, therefore you will go here and there and sit, but not in the order. So you wanted to sit together, but when you come, you can see the space is not there continuously. Therefore, you go to different places and sit. I hope you understood that example, right? So let's say these are the seats. This is the bus, and the bus has seats. So bus has seats, and some seats are filled. Some seats are filled. Okay, you can see this, and then so let's say some seats are filled. So this seat is filled. This is filled. When you come to the bus, you can see this seat is filled. This is also filled. Likewise, some seats are filled. These two are filled. And when you come to the last, you have to sit here and there. Your friends may be single file. So single file can be stored this way. One part here, another part here, another part here, another part here, and here another part, here another part. Likewise, then it is called fragmented allocation. Fragmented allocation. Right, okay. Then when these are allocated, so that is called fragmented allocation. Fragmented allocation, allocated here and there. The other way, the contiguous allocation means you allocate continuous spaces. Let's say you have another file, very small file or some other file, but allocated space this way. Continuous sectors are allocated. That is called contiguous allocation. Right? Which is convenient, fragmented or contiguous? Which is convenient? Yeah, what do you think? Which is convenient? Is it contiguous? Contiguous means adjacent spaces allocated. Fragmented means the different spaces from different locations are allocated. So which is good? Is it fragmented or contiguous?
Fragmented.
Fragmented is easy, but the contiguous is more neat, right? Fragmented is quick. You can allocate quickly because here and there you can put quickly, but the contiguous will be more efficient, right? Because when you retrieve the file, the entire file can be retrieved quickly. When you save the file, maybe the fragmented is option, because when you can't find the spaces together, then fragmented is there. But when you open the file, the contiguous will be better. Contiguous can එකලඟ තියෙනවා. ඒතකොට ටග් ගාලා communicate කරලා open කරගන්න පුළුවන්. හැබැයි fragmented හොඳයි ඉක්මනට save කරගන්න. After some time, you can do this because after doing this for several times, your disk will be really unordered. Like your disk will look like a mess. Different part of the files are in different locations. Different files of the files are in the different locations after you put in there. So that can be there. Okay. Then, and I also explained the size of disk. You can see this is the cluster size, and size on disk is this green color filled one, and cluster is allocated. You can see the 3 sectors are clusters, so cluster is allocated, but only one is filled. So this will remain empty, right? These sectors will remain empty. That is also another problem. There will be empty areas, empty sectors. There can be empty sectors. And also due to this contiguous and allocation and fragmented allocation, due to fragmented allocation, the disk can be disorganized. So what you can do? You can defragment. Defragment means you can see the different files are in different locations, but you put the same files into the same location, adjacent. Another, these 2 also adjacent. These 2 also adjacent. This 2 also adjacent. These 4 also adjacent. Then you can see it's really organized and will be faster. So there is a tool to defragment your hard disk. After some mess up, after messing up for some time, you can just think about, right? You can just think about defragmenting this. I think these points, it's better to write down and draw quickly. I'll quickly revision and I'll quickly, actually not revise, I'll quickly summarize about this process and memory management. So similar to the files, there are different users using the files, and file is a resource. Process is also a resource. Process is a program in execution. We learned that. What is process? A process is here a program in execution. A running program is known as a process. There are multiple processors fighting for the resources in the computer. There are multiple processors and they're fighting for the resources in the computer. So it is required to manage these processes. Basically, one of these diagrams will be there in your examination related to the process management. I'll quickly tell about that. So any process which is like aimed to run, which is planning to run, should first come to the ready state. Only the processors which are in the ready state can run. So we have to start from somewhere. No? We have to start from somewhere. A new process. Let's start with the new process. When there is a new process, the new process will first go to the ready state. Process it will admit to the ready state. When it admit to the ready state, it will be there in the ready state, and ready process can start running. A ready process can start running. Ready can be running or ready can be suspended. Why a ready can be suspended? Because if there is an error in input-output operation, or if there is an error if it is timeout. So you want to run it, but timeout. You want to run it, but there is some resource issue. So it can be suspend, right? It can be suspended, right? So that is one thing. A suspended, this is temporary suspension. It can be activated back and be ready. And the next stage of ready is running. A ready process can be running, right? Ready process can be running means it's using the resources and it's in the processor. And after some time with the schedule, because each and every process have a it has a schedule. So do this process. So it will, after some time, the process can be dispatched, or process can be stopped and become ready again, because there are multiple other processes running. So that multiprocessing computers in the multiprocessing environment, so the processor need to give spaces to other processes also. Therefore, a running process can be dispatched and it can be ready again. So note the arrows. These are very important. New eking in puluwan ready wallet. New process can be ready, and ready process can be running or suspended. And a running process can be blocked. Running process can be blocked. Block means something serious. Block means the process is removed. Process is removed and put into the block list. Can be input output error or some other error. It can be blocked, right? So it's sent out, and then so the block process cannot run again. Block again run when the block process cannot run again, but it can be ready again and run. Ready vela run when puluwa. New ekakata ready vela run when puluwa. Block ekakata ready vela run when puluwa. And there is another thing. So that is permanent termination. If a process is terminated, it cannot come back. It has to start from the beginning. If a terminated process or killed process, we call killing. Killed or terminate process cannot run again. So it need to start as a new process. And the block process, blocked one can be suspend and block. So when you suspend and block, you can reactivate to the block state. So these additional arrows will not be asked in the examination mostly, but you need to know about these 3 points. Ready process, and also running process, block process. Running can be blocked, block can be ready again and start running, right? Preempted means, so preempted means it is like decided to make ready. Preempt means it's planned for some time, and after that it can be ready. Running again, planned for some time, it can be ready. Running, ready can be interchange, because there are some other processes that එකක් run වෙනවා. එයා ready වෙනකොට තව එකක් run වෙනවා. එයා ready වෙනකොට එහෙම කට්ටියට මාරුවෙන් මාරුව දෙන්න පුළුවන්. And this is a new process. New process need to be ready. And process is terminated, process died or killed process is called terminated. Here terminated process. So this diagram is, I think, easy to understand. So this is block process. Block process cannot be run again, need to be ready. After ready, not it can be run. Or the block process can even be killed or terminated. And a ready process can also be killed or terminated. In any state, the process can be killed or terminated or die. So please draw this diagram, and no need to write down notes. I'll explain the balance, remaining things after that.